So let's continue with the lecture for OpenCV tutorial. So now we're gonna take a look at how to implement the k-means algorithm for image segmentation, and after this we're gonna talk about the programming assignment number 2. So as we saw in the previous slides, we know that the k-means algorithm is a very simple but very interesting algorithm in which we can cluster different data points based on different similarity, for example. So this is like for a simple case, but we can use this for a more complex scenarios in which we don't not only we don't only cluster points in one dimension, but we have different dimensions. For example, we have in the 3D space for RGB values of a color image. So if we input an image that like the one that is showing the left, we can see that depending on the number of clusters that we define, we can get an image that like the one that is shown on the right. So let's take a look at how the actual algorithm works. So in this case, I'm not gonna be going through all the line by line, but I'm gonna talk about more in detail about like the different blocks of code work. So let's take a look at the initial block, in which first we're reading an image, okay, and then we're checking whether the image is correctly loaded, and then we're just displaying some information about the image. In this case, the rows and columns which indicate the height and width of the image. And in this case, we're also checking whether we have more than one channel. In this case, we have 3 channels for a color image. So the next block, we can see that we are using we're creating a different image called reshape image, and this reshape image has one dimension, and which is one very long vector, and this is based in, well, the size of this vector would be basically the number of columns times the number of rows, which is the width times the height. And so why are we doing this? Well, basically the function of k-means requires a matrix in which each row corresponds to a coordinate of a point. So in this example, okay, the coordinate of the point is an RGB pixel basically. So we need to meet this requirement, and the matrix image must be modified by using the function of reshape that we can see here. So after modify, so the image will translate, instead of having a three matrices, it will have only one long vector. So let's take a look at the next block. Here we are creating also another reshape image, but this time is for a 32-bit flow. So why is this? Well, this is also because the k-means function that we're going to use later on, it also requires a matrix that consists of floating point elements. So this is why we need to also create a different matrix, and we convert this by using the convert to function, as you can see here. Okay, so again, as I mentioned before, this reshape image must be converted into a floating point for an image by applying the function that you can see here. So in the next block, we can see that we are creating another images. In particular, these are for preparing the outputs of the labels and centers, which are the centroids of the k-means. Okay, in this case, we are also creating the number of clusters. We are just defining a particular integer to define how many clusters we want in an image. Then we also have a new function that a new variable, a new structure that we see that we have not seen before, which is term criteria. This is a structure so we can specify a particular parameters for our k-means function. Okay, in this case, In this case, the number of maximum iterations will be 100, as you can see here, which is after it iterates for 100 times, then the program will quit, or the algorithm will stop clustering. Okay, so the final argument that you can see here in this term criteria, okay, is it's not really used. Basically, it's just performing a constant number. Okay, and right now, finally we are using the actual function of k-means. So this function is the one that basically performs all the clustering of the data that we are providing. Okay, and at the end we are just showing the result. But as you can see here, the show result function is a function that we created. So we're gonna also take a look at this function more in detail, because we're providing 3 parameters. 2 of them are different images. One of them is the labels, the other one is centers, and the other one is just the width of the image, which is the rows. So, but before that, let's take a look at the k-means function, because you know there we have several parameters, and we want to know what these parameters are for. So this is the function that we are looking at. This is the k-means function, and then, well, initially we have the samples. In this case, it's just the input, which is a matrix containing the actual data points that we want to cluster. Okay, the second parameter is a cluster count. That's the number of clusters in the data points. So this is basically the number of centroids that we want. Okay, then we are providing another matrix called labels, which returns basically the cluster of each point that each point belongs to. Okay, then we are providing the actual information of the criteria for our k-means. So this is where we define already, you know, that we want only, you know, the certain number of iterations. In this case, we're just defining 100 iterations. Then we're in the next parameter, it's a attempt, which is just the number of times we want the algorithm to run with different center placements. So this is just another parameter that needs to be specified. And then we also need to specify the different flags. Okay, and this is for different options that we have. Usually the most common one is the one k-means random center. Okay, in which basically the centers are generated randomly, because at the beginning usually the k-means requires this random placement of the centers. But sometimes we also want to specify the position of the centers. In this case, we can use a different flag for k-means pp center, as you can see here. Okay. Also, sometimes we also want the first iteration to use some labels that are supplied already to calculate the centers that are going to be used initially. So for this, we're going to use the different flag for initial labels. And finally, the last parameter, which is one of the most important, this is where we are going to get the actual output, which is the matrix that holds the center of each cluster. So now let's take a look at the other function in which we just show the result. Okay, again, the first block, this is to display some information about the data that we are obtaining, in which the variable labels indicates a one-dimensional matrix. Okay, each row of it has a value of the label basically. Okay, and then if the cluster number, for example, is 3, okay, the value is either 0, 1, or 2. Okay, and variable centers, a variable center is just the cluster times the matrix, which in this case is 3. Okay, so each row of this, you know, has a coordinate center of the cluster. So in this case, for example, the coordinate corresponds to the vector specified in the RGB space. So yeah, this is basically how we are just displaying the information. So let's take a look at the other images. Well, this image is basically just, you know, preparation just to display the final image. Okay, so it's just where we're gonna place the actual image that we want to display in the output window. Finally, we have the actual matrices that contain the floating point values for the centers. Okay, so first these values, they need to be converted into different type. Okay, which is basically it ranges from 0 to 255 because it's for 8 bits. And then we also have the channels also need to be translated into 3, because originally we had to translate into one long vector, and now we are going to reshape into a 3 channel matrix. And then in the last block, as we can see here, basically we're just we're just replacing the corresponding RGB value by the label, and this is to make just the final image that we need to display, and at the end we just display this image into the window. So this is basically how the actual algorithm works. So let's take a look at the actual results. So if we have, for example, this is the initial image, then let's say we specify okay, I'm sorry, yes, this is wrong. Okay, yeah, I made a mistake. So for example, let's say we specify the k equal to 10, which is we want 10 clusters. Okay, so in this case you see that we still can notice some of the original colors of the original image, but then if we lower the number of clusters to 5, then we're gonna see some changes, because some of the color pixels are being quantized into different clusters. In this case, only 5 clusters. And then let's take a look at 3 clusters. Now we can see a more segmented image, as you can see here, based on only 3 clusters. And finally, if we have, for example, only 2 clusters, this is the actual result that we're going to get. So this is the k-means algorithm. I hope that you get the concept of it. You can grasp an idea of how to actually implement it, because this is something that we're going to use for our next programming assignment. So let's take a look at the programming assignment for the next I think it's going to be due in 2 weeks. So in this assignment you will implement an interactive image segmentation program. So this segmentation shows also the RGB color histogram information. So let's see how it works, how it's supposed to work. So first, what the program should do. First, the program should load a particular image, okay, and then display this image in a window called original, okay. Then the program should allow the user to select a sub-region of the image using the mouse. So basically we're gonna select just one region of the original image, okay, by using the mouse. And then the program should extract this sub-region of the image and display in a new window called segmented, okay. Then at this moment a color histogram, okay, for RGB contained in a new window called histogram should be calculated for the new image display in the segmented window. Okay, so basically once we extract the sub-region of the image, we are going to put it in a new window, and also we're going to calculate the color histogram and place it in another window called histogram. Okay, then the segmented window will contain a trackbar that corresponds different key values to be used for the k-means algorithm. So the new window that has only the sub region of the image will have a trackbar in which we can manipulate the different values of the k-means. So when the user changes the value of the trackbar, okay, the k-means algorithm should be applied to the image containing the segment window, and also at the same time the histogram should be updated with by calculating the color histogram of the new image that was changed by the k-means. So let's take a look at a graphical example. So first, as you can see here, we have the original window, which is for example, this is supposed to be the image, right? The original image. Then we are going to allow the user to select a sub-region, in this case just a rectangle, okay? And we're gonna do this by allowing the user to click only 2 points, basically the upper left part of the region and the lower right part of the region, and then automatically the program should create a rectangle. So this rectangle is basically the area of the region that we want to use as a new image. So this region will be displayed in a new window. In this case, it's going to be called segmented, and this new window will contain the trackbar, as you can see here in this example. So this trackbar, we can change the position of the trackbar, and these are just by changing the different k values. So when we change a k value, basically the algorithm should perform the k-means segmentation, and then we should see the changes in the same image, and at the same time we should also see the color histogram in a different window called histogram. So it's going to be more interactive, because whenever we change the k value, the new window, I mean the new image should be displayed in the segmented window, and at the same time we can see the changes of the histogram. So this is the actual program. So let's see some of the specifications. Well, the program should display the original image immediately after initialization. And also for user interaction, they will be through the mouse. In the previous programming assignment, the interaction was through the keyboard, but this time it's going to be through the mouse. So for selecting the image subregion, so the user needs to click 2 points of the original image, the upper left and the lower right corners. So when the user finishes selecting 2 points, a red rectangle should be drawn on top of the original image, specifying the region selected. And then for selecting the k values, the user needs just to click and drag the trackbar value pointer just to change the values. The maximum number of k values should be 10, and the minimum should be 2. So that's basically the number of clusters. Lastly, the RGB histogram should be displayed in the same window. So basically, we're gonna have one more window called histogram, and all the 3 histograms for blue, green, and red should be displayed in this window. You don't need separate windows for each channel of the histogram. You can put them in the same window. So what to submit? We need to submit, well, here is a zip file, but we're not going to use the zip file. We're actually going to use the online platform to submit all the files. So you need to submit the C++ code, okay? Again, your name and the last name for the file name. And then you also need to submit a Word file report containing sample result images for k-means and histograms for 3 particular values. I want for 2, 5, and 9 clusters, and then a total of 6 images should be included, which is basically 3 images for the k-means and 3 images for the histograms. And basically you should also include all the image files whenever you upload all this information to the online platform. So the due date is October 7. Okay, and here I also put some other references. Okay, this is, for example, this is where you can find code examples of how to extract a subregion of an image, or how to perform k-means or histograms. Again, if you have any questions, just please let me know by an email. Okay, thank you. Good luck.